So in this tutorial, we're going to see how we can export balanced representations from the PDB import kit to formats that can be easily interpreted by other 3D software. So this is a feature that should be coming to Molecular Maya very soon, but in the meantime we can create mesh networks to convert instances such as these spheres and bones into mesh objects. So let's start by creating a geometry for our atoms. So we could either use spheres or platonic solids. That should do the job. And now let's create a mesh network. So we can either go in FX, mesh, and create mesh network, or go in the mesh shelf over here and click on this button. So make sure that you have mesh loaded in your the mesh plugin loaded to have these menus. And so once we have that, let's open the node editor. And here we can see that we have a mesh distribute node, which is while creating copies of our sphere and distributing and placing it in space. It's sending its data to the mesh waiter node, which is the main mesh node, which itself is sending data to the mesh repro node. So the mesh repro node is like an instancer, but it outputs a mesh. And what's particularly interesting for us is that it uses the same input data as nParticle instancers. So you might see where we're going with this. Let's select our nParticle node that's displaying the atoms and display it in the node editor. So we can't see it by default because the node editor is is grouping the nodes inside assets. So we need to uncheck that option. Then I can select the nParticle again. Click here, and we should see the chain A particle shape over here. So let's create an instancer in FX particles instancer. We need to create to select the whole object and not just a single particle. So instancer. It's a bit of a mess, so I'm going to select the instancer in the outliner and only show the inputs. I'm going to control click on mesh repro and do the same thing. So here we have our nParticle network, and here the mesh. What we'll want to do is get the plug from the nParticle shape that is sending data to the instancer and plug that in the mesh waiter. So I'm just going to disconnect that and plug it in here. And as soon as we do that, we see that the mesh network did place spheres on each atom. So we have our atoms, but we now need to set the scale of the atoms. So to do that, we'll need to create a Python node because the data in the nParticle shape node isn't directly compatible with the mesh network. So we'll use Python for that, add Python node. This will create a node in between the nParticle shape and the mesh node, and we'll be able to modify the data that's been given to the Python node and process it and give new data to the mesh waiter. So when we click on the mesh Python node, we can enter some Python code here. Let's see the code over here. So So this part is the code that will copy and paste here. So what it does we create a mesh data object that we can use to query, to get some attributes, get the data that's given to the Python node. And we can also use that mesh data object to set output data like the scale or positions or rotations or etc. And so the data that we want to output will depend on data in chain A particle shape. So we're going to use the cmds.getAttribute function to get the radius per particle attribute, and then we're going to loop over each object and set the output scale to be equal to the input scale times radius per particle. And then we use md.setData to set the output. So let's select the Python node. Alright, I've already pasted the code here. So if I update the frame, we should see that meshes now have the same radius as the end particles. So we can go back into molecular Maya and change the atom radius. It will affect the mesh node. So now the next step is to create a mesh network for the bonds. So we'll start by creating a cylinder, a reference geometry for the bonds. Alright, we'll need to adjust the orientation of the bond, the position of the bond later on, after it's being instanced. So we'll parent this cylinder under group. So Control G, I'm selecting the cylinder in the outliner, hitting Control G, I'm calling that reference bond geometry, so that when it's instanced, the transform of this group will be overwritten, but the child transforms won't. So let's create a mesh network out of that. Alright, if I show the reference geometry here, if I apply some transformations to the ref bond geo, nothing will happen. But if I apply some transformation to its child, it will affect the instance geometries. Alright, so now let's find the end particle node that is instancing the bonds. So let's display the connections of chain A particle shape. There's a bunch of nodes here, so we can look for another end particle node, or we can use this filter. So asterisk to select any characters, then particle, then any other character. So now that we've filtered our nodes, we can see that we have our chain A particle bonds shape. So we can select that, can remove the filter, select that, and create end particles, create an instancer. So again, it's a bit of a mess here, so I'm going to select instancer 2 in the outliner and show its inputs. Alright, and also select mesh to repro mesh. To see the mesh and particle bonds network. So we're going to do the same thing as we did before, plug the instance data to the mesh network. So we now have the cylinder placed where the end particles that are used to instance the bonds are, but they're not oriented or scaled properly. So to do that, we need to create a Python node again. So Python, create Python node. And here's the code that will be used to show them. So this is similar to what we just did. So we're getting data from the end particle bond shape. So we're getting bond position, bond unit vec, and bond scalar. And so in this end particle node, there are more bonds than there are particles. So let's call that n bonds equals length of bond positions. We're setting the point count, so the number of output objects, to the number of bonds. And then we need to convert the aims, the bond aims as angles, as the mesh network works with angles. So we're using that function, angle between. And once we have everything that we need, we can set the output position, output rotation, and output scale. We also need to switch the X and Y components of bond scale. So we set a bond scale, we start by 1, then 0, then 2. And yep, so once this is done, let's go back into Python, update the frame. And this is what we should get. So let's select the cylinder, adjust the radius. And we see here that the bond seems to be properly oriented, but not properly placed. And that's because the reference geometry should be a sort of unit cylinder. So its height should be of 1. And the bottom of the cylinder should be at 0. So we can set that to 0.5, translate to 0.5. And now, yeah, we see that the bonds are correctly placed and oriented. All right, so if we want to have fancier bonds, we can add some subdivisions in the height of the cylinder. Let's say 12. Go in modeling, deform, nonlinear, and flare. And adjust the curve. Let me hide the molecule. All right. Where's the flare? Okay, and then adjust, for example, low bound. Oops. Adjust high bound so that we get the desired effect. All right, and so now once we have our two meshes, so mesh 1 repo mesh, which corresponds with atoms, the second to all the bonds, well, I'm going to duplicate these. Oops, duplicate, so Control D, select these two and mesh combine, so that I end up with a single object. And then I can select that and export selection, either as an obj or a FBX. So in order to have these options, make sure that you have the plugins loaded. So plugin manager, FBX. So make sure that you have game FBX exporter or obj export loaded, and then we can export the selection. So here I've just opened an Unreal Editor window and imported the object that we just generated. And as we can see, the geometry displays properly. We can move it, apply some rotation, and etc. And so right now we can't have a per atom color. This is something we'll see in our next video. So in the meantime, I hope you can have some fun with these tools, and hope you enjoy it. Thanks.